Hello everyone. Today we are going to discuss a very important topic, Grignard reagent. And let's start. So Grignard reagent is basically RMGX. RMGX. So the bond between R and Mg is covalent bond. This is covalent bond. While the interaction between Mg and X is ionic. We all knew this is plus, this is minus, and R is delta negative. Clear? This X can be chlorine, bromine and iodine. Okay, in general. And this R minus, it can act as a nucleophile as well as base. So these two reactions are very important, the nucleophilic reaction as well as acid-base reactions. So first we are going to discuss how to make this Grignard. What is the method of preparation? So let's talk about method of preparation. So suppose we have alkyl halide and we are going to treat them with magnesium in the presence of ether. So magnesium will insert between this RX bond, so it will become RMGX. Clear? Suppose you have this chlorine and we are using Mg in the presence of dry ether. So Mg will be here, so it becomes MgCl, where this carbon is a nucleophilic as well as basic in nature. Clear? Delta negative and this one is delta positive. So this is the way we can make the Grignard reagent. And now let's talk about the reactions of Grignard. If you look at this R, so I am going to write here the nature of reaction. First, it can give acid base. Second, nucleophilic addition. And the third reaction is nucleophilic addition, then elimination. So I am going to discuss what is acid base reaction, what is nucleophilic addition, and what is nucleophilic addition, then elimination with examples. Okay. So first of all, let's start with acid base reaction. Suppose we have this Grignard CH3MgBr. If you have any proton here, suppose any acid, suppose H plus, so this CH3 negative will grab this proton and become CH4. So this is called acid base reaction. Now the next is nucleophilic addition. Suppose we have any aldehyde or ketone and we have any nucleophile, suppose. So this is a nucleophile and this carbon is electrophilic in nature. Okay, because CO bond is a polar bond. So oxygen is delta negative and carbon is delta positive. So nucleophile is going to attack on this carbon and this bond is going to break. So as a result of it, it will be CO minus, here H, here nucleophile. And in the next step, we have a proton. It comes from, suppose, water or acid. So O minus grabs this proton and it becomes alcohol. So as you can see in nucleophilic addition, the nucleophile attacks first. That's why the name is nucleophilic addition. And then CO bond will break and here you have O negative and the next step O negative is going to protonate. So this is the final product in nucleophilic addition. Now the last one is nucleophilic addition, then elimination. So here we can say, suppose we have this type of carbonyl compound, this is leaving group, okay, and here we have a nucleophile. So nucleophile is going to attack on the carbonyl carbon because this carbon is electrophilic and this bond is going to break. So overall we have this type of intermediate, O negative, here leaving group, and here you have a nucleophile. Now O minus will revert the electron and leaving group leaves. So we can make this one C double bond O Nu. Clear? Now carbonyl can again react with nucleophile. Clear? It can again react with nucleophile because we have seen before, you can see carbonyl bond and nucleophile can attack and it can form alcohol. So same here, it should be like this, O minus, here Nu and here Nu as well, and in the next step it will protonate and your final product will be alcohol. So if you have this type of reactant, then you can see 2 mole of nucleophile is used to convert the starting material into alcohol. Make sense? Suppose you are going to start the reaction with the Grignard and you have this type of reactant, then 2 mole of Grignard is used to convert the reactant into the product. Clear? So what should be here leaving group? So leaving group can be here halogen. It can be OR as well, means it can be ester, it can be acyl halide, okay. So this is all about the general information of nucleophilic Grignard reactions. Now let's start with the very first one, acid base. Grignard as acid base. So first of all you should know what is acidic hydrogen. What is acidic hydrogen? So here we have few conditions. Condition 1, hydrogen must be linked with fluorine, oxygen or nitrogen, so this is acidic. Second condition, triple bonded carbons, hydrogen is acidic. Third one, if you have active methylene like this, suppose this is withdrawing, this is withdrawing, and these 2 hydrogen are acidic. Clear? So these 2 are withdrawing one ketone and this hydrogen is acidic. What is acidic? Acidic means easily ionizable hydrogen. Here we can say easily ionizable hydrogen. Clear? So suppose you have the Grignard and we are going to treat them with water. Okay, I think I should discuss in the next slide. Suppose here we have Grignard and I am going to react them with water, alcohol, acid, amine, here we have unknown product A, B, C and D. Here we can draw another one. Suppose we have CH3 C triple bond H. Clear? And suppose this is E. Now we have to make the product, the unknown A, B, C, D and E, the structure. So look at here, this is CH3 which is delta negative, and I said that if we have acidic hydrogen, then Grignard can grab those proton and it can make a hydrocarbon. So this CH3 is going to attack to this proton and it can form CH3H, and CH3H is nothing, it's just like CH4, okay, methane. Here we have again acidic hydrogen, so this CH3 can grab this proton and again CH4. Here as well we have acidic hydrogen, again CH4, again acidic hydrogen. So this CH3 is going to convert into CH4, and again we have acidic hydrogen here, so it will be CH4. Makes sense? So whenever we have acidic hydrogen, R part, Grignard, the R part means alkyl, it can grab the proton and it can become a hydrocarbon, okay. And if you are going to talk about the byproduct, this is the major organic product. The byproduct quite simple. Look at here, the left part is MgBr and here the left part is OH. So this MgBr is going to connect with this OH in this form. Mg here OH, here Br, like this. Same here, MgOCH3 and Br. Here as well, Mg OC double bond OCH3 and Br, and here as well Mg C triple bond C CH3 and here Br. Clear? As well here Mg NH2 Br. So this is acid base reaction, which is very important, okay, and acid base reactions are the fastest one. Now the next is nucleophilic addition. Suppose we have this carbonyl one, suppose aldehyde, and we are using this Grignard CH3 MgBr, or suppose this one CH3CH CH3 MgBr, and here we have water. So look at the mechanism. This is a attacking site CO, and this is my nucleophilic carbon. So it attacks on this carbon like this. Here we have O negative, and look at this nucleophilic carbon, it is CH. So you can draw CH, and now look at the rest of the connectivity with the CH. He has to have two methyl connectivity, so CH3 as well as CH3. In the next step, we have suppose water. So this O minus grab this proton, so it becomes alcohol. Here OH, here like this. Make sense? So this is a nucleophilic addition. We have plenty of examples like this. Suppose a question, suppose it is treated with, this is my alkyl halide, suppose Cl, it is treated with Mg in the presence of ether, and third one is H2O. What should be product? So look at here, this combination is to produce the Grignard like this. Mg in the presence of ether, Mg is going to insert the carbon chlorine bond like MgCl. This is my nucleophilic carbon, the yellow one, and now we have this ring. So what will happen? This carbon is going to attack on this, so it will break like that. Here we have OH after protonation, because this is O minus, and after with water it can grab the water's proton and it can become OH. Now look at this connectivity. This is very important. The nucleophilic carbon one. You know, whenever you are going to connect, you can mark this as number 1. So number 1 is directly bonded to this carbonyl carbon. Suppose this is my carbonyl carbon, which is number 1 carbon. This is carbonyl carbon. Now look at the rest of the connectivity with number 1. Number 1 has this connectivity. So keep any side bond, suppose like this. And then downside a carbon, and then there is another carbon in the left and 2 carbon in the right. So as you can see, makes sense. This is the nucleophilic part. Clear? So this is nucleophilic addition. Now let's start the nucleophilic addition, then elimination. You know, what is the trick behind the last reaction? Let me discuss the trick for nucleophilic addition. Suppose you have this nucleophile, my carbonyl, and this is supposed to be MgBr is my Grignard, and here we have water. So look at the simple thing. This is C double bond O. You have to attach a nucleophile with this carbon and a proton with this oxygen. Simple. This is a nucleophilic addition of Grignard. So nucleophile attack to the carbon. So first of all, you should identify nucleophile. Nucleophile is this carbon one, the entire ring. Okay, this is the nucleophile. So you have to connect with this carbon. So you can see. And this oxygen grab this proton, so become OH. And now look at this nucleophilic carbon. So bond and then again 6-member ring. Simple. Clear? Now the next is nucleophilic addition, then elimination. Suppose we have this carbonyl, and here we have this Grignard CH3CH2 MgBr. Suppose CH3CH CH3 MgBr. Oh, sorry, here we should use a leaving group one. Suppose chlorine. Okay. So 1 mole of Grignard is used to eliminate this chlorine as a leaving group. So look at here the reaction. It attack over here, it breaks like this. Now look at the bonding. CH. This one has 2-methyl. I said that in the previous slide, O minus is going to revert the electron and Cl leaves. So it will form this product. Clear? Now this is ketone, it can again react with Grignard, same mole of Grignard, so CH3 MgBr. So what will happen? I'm just going to convert O into OH because after protonation it can become OH. So look at the trick here. Oh wait. So look at the trick here. This is a leaving group. 1 mole of Grignard is used to eliminate this chlorine. So this is a nucleophile. It can again react, this is a nucleophile. It can again react with Grignard and there is a 2 mole of nucleophile in a final product. So what is the trick behind it? You have to attach the Grignard part, the R part 2 times with this carbonyl carbon and oxygen into the hydrogen. Look at the reaction. This one. Suppose we have this reactant Here we can use ester this time, because ester is also OCH3 is a leaving group, and we are using this one. So I'm just going to draw the final product. So look at here, this is the nucleophilic carbon. So first mole is, you have to, what you have to do, look at, this is the leaving group and this is the RMGX. Okay, 2 mole of RMGX is used to convert this reactant into the final product. So like this, C double bond O, after this it will become, look at here, see, oxygen becomes OH, and these two valencies your Grignard, the R part. Clear? We will do the same thing here. This oxygen will be OH, this is a carbon, and these two valency your nucleophile. So 2 ring here like this. Clear? So this is a nucleophilic addition, then elimination. Grignard reaction with CO2 is also very important. I am just going to tell you a trick. Look at here. If you have, suppose, this type of Grignard and it is treated with CO2, the simple thing is that eliminate this MgBr and add carboxylic group. Simple. You have to attach a carboxylic group in the final product. Clear? Suppose you have this type of Grignard and we are treating with CO2. Eliminate this and attach with carboxylic. Easy. Clear? So this is the Grignard with CO2. There is a reaction with the cyanide as well. RMgX with cyanide, C triple bond N. But before this, I just want to discuss a process which is called hydrolysis. So look at here, what is hydrolysis? Suppose you have this type of bond RCH2 and H2, and we are going to hydrolyze this H plus. So look at here, you have to write HOH, water, in this way. Nitrogen and carbon, look at here. Nitrogen is more electronegative if you are going to compare with this carbon, and in water hydrogen is less, oxygen is more. So this more electronegative element, look at in this way, even you can say negative, positive, positive, negative. Now look at the interaction, this negative grab this positive, the hydrogen, so it becomes ammonia, and here RCH2OH, RCH2OH. Clear? If suppose we have double bond here, if double bond, then we can use 2 mole of water. If double bond, then 2 mole of water, like this, suppose. So we can use 2 mole of water, HOH, HOH. Again the same concept, negative, positive, positive, negative, positive, negative. So nitrogen, remove both hydrogen and it again going to become ammonia. And what is the product here? This CH has 2 OH. Clear? And whenever a carbon has 2 OH group, it is highly unstable, so there is a loss of water. So if you are going to remove water, OH and H, it becomes CHO. and CHO is nothing, it's aldehyde. Clear? Suppose we have this one, C triple bond N, and we are going to hydrolyze this. So this time we will use 3 mole of water, HOH, HOH, HOH. Again nitrogen, remove all the hydrogen, and again ammonia, and it will be what? RC3OH we have this time. Again we are going to remove water molecule because again it is unstable. So OH and H. So it will be what? R, C, have a OH, and this oxygen is a double bonded because carbon valency is 4. So you can see this is carboxylic acid. So whenever you are going to hydrolyze cyanide, it gives you carboxylic in place of CN. Make sense? So let's talk about the reaction of Grignard with cyanide. Suppose we have CH3 MgBr and here water. I am going to remove this R and I am going to keep here CH3. So this nucleophile is going to attack over carbon and this bond is going to break. So as a result of it, it will be CH3C, CH3 double bond N MgBr, okay, N MgBr. Now we are going to hydrolyze here. We have double bond, C double bond N, so we can use 2 times water. 2 times water like this, HOH, HOH, and look at here, CH3, C, CH3, OH and OH. And I said that a carbon has 2 OH, always unstable, so there is a loss of water, so it becomes ketone, CH3, CH3 double bond O. So this is the final product. Clear? So simple thing is that you have to convert this carbon into CO and attach with this CH3. Make sense? Suppose this is the trick. Suppose you have this type of cyanide and we are using here CH3, CH3 MgBr. So this is a nucleophile, okay, it will attack on this carbon. So final product, look at here. This is the carbon double bond oxygen, and here you have to attach CH with twice methyl. Clear? Simple. So this is the nitrile reaction. Now the very last one, conjugated enone with Grignard. So this is 1,2 di addition. This is 1,2 addition, sorry. 1,2 addition. What is 1,2 addition? This is 1, this is 2, this is 3, this is 4. So nucleophile attacks over 2 and this bond is going to break. It becomes O negative and here you have CH3, and after protonation it becomes OH. So this is the final product. Clear? And this is the last one in Grignard. So this is all about the Grignard, which is very important when we can use this one in the synthetic route. Okay, so please try to watch this video and write down everything in your notes and revise it properly. Thank you so much for watching this.